Welcome to This Explainer. Today, we're going to master absolutely one of the most critical tools in all of construction project management, the work breakdown structure, or WBS. If you want to know exactly how a professional planning engineer actually controls a massive, complex construction project, well, you're definitely in the right place. Let's get into it. Okay, here is our roadmap for today's deep dive. We'll quickly define the WBS, then systematically break down a commercial building structure. After that, we'll hit the unbreakable rules of planning, trace the workflow straight from the WBS to project control, and finally, define the active day-to-day role of the planning engineer. Section 1. Let's establish the fundamental concept of the work breakdown structure. So, before a single excavator even hits the dirt, every planning engineer has to answer this one massive question. What work actually must be completed to deliver the project? You can't just write build commercial building on a schedule and call it a day, right? It's just too vast. The solution to that problem is the work breakdown structure. Think of it as a hierarchical breakdown of your entire project scope into smaller, much more manageable components, which we call work packages and activities. By logically slicing the project up, it becomes infinitely easier to plan, schedule, resource, and ultimately control the whole shebang. Section 2. Let's look at a commercial building WBS structure in action. We always start right at the top of our hierarchy. This represents the ultimate, complete goal of the project. Literally 100% of your scope lives right here, sitting under the main umbrella of construction of commercial building. From there, we branch out into these 9 major work sections. This is the primary trunk of our WBS tree. And notice how it moves logically and chronologically. We go from project management and site prep, down into the dirt with foundation works, up into the sky with the superstructure and masonry, then threading the systems with MEP, dialing in the aesthetics with finishing and external works, and wrapping it all up with testing and commissioning. Now, the real magic happens when we drill down to the next level. Let's look at those first 2 sections. So 1.0 project management breaks down into actionable packages, like 1.1 mobilization, which is physically bringing personnel and equipment to the site, and 1.2 site office setup. Meanwhile, 2.0 site preparation is divided into tangible, schedulable activities, like 2.1 surveying and 2.3 excavation. We're taking these massive, broad concepts and turning them into real, specific work. Continuing downward, we hit the heavy civil work. 3.0 foundation works isn't just one giant task. We split it into layers. You have 3.1 plain cement concrete, basically the blinding layer, and 3.4 concrete pouring. Once we're finally out of the grounds, 4.0 superstructure takes over, branching neatly into 4.1 columns, 4.3 slabs, and so on. Every single structural milestone is isolated here, so it can be accurately resourced later on. And as the building really starts taking shape, the complexity goes way up. 6.0 MEP works encapsulates all those highly technical systems, categorized logically into 6.1 electrical, 6.3 HVAC, and the rest. Same goes for 7.0 finishing works, which details out 7.1 flooring, 7.5 doors and windows. This ensures that when we finally schedule out the architectural finishes, literally not a single trade or material gets overlooked. Moving on to Section 3, let's talk about WBS codes and the rules of the game. This numbering system we've been using, it's definitely not just for show. Notice the parent-child relationship. 4.0 superstructure is your parent major work section. Beneath it, 4.1 columns and 4.2 beams are the child elements. This code provides a unique identification structure. It's essentially the exact DNA language that project control software uses to link a very specific task on site directly to your overarching budget and schedule. And that brings us to absolutely the most unbreakable law of project planning, the 100% rule. The 100% rule dictates that the combined scope of all your WBS components must equal exactly the entire project scope, no exceptions. If your WBS is only 80% of the project scope, you've got fatal scope gaps, meaning work is literally missing from your budget. But if it's 120%, you've somehow allowed uncontrolled out-of-scope additions to sneak into your baseline. It must be exactly 100%, period. All right, Section 4, we've built the WBS, we know the golden rule. Now, how does this actually work as the engine for project control? Well, the WBS isn't just a static list that sits in a drawer. It's step 1 in a very dynamic chain. From the WBS, we generate our schedule of specific activities. To those activities, we assign our cost,
and our resources. Once the project actually kicks off, we track progress by constantly comparing our baseline plan against actual field data. And finally, that leads to control, where we conduct variance analysis to keep the whole thing on track. The WBS is the anchor for this entire chain.
To put that into perspective, let's look at a planning engineer's day-to-day reality. Take WBS Code 4.1, constructing columns. Because we built a clean WBS, we can easily link this code to a specific structural crew and a very specific budget. Week by week, we measure the planned versus actual percentage. If those columns start ragging, we instantly know exactly which crew is affected and precisely how it's going to impact the superstructure's timeline. It's a game changer. Which brings us to our final section, the active, highly crucial role of the planning engineer in managing this ecosystem. The planning engineer's workflow is typically this 12-step process. In the first half, you're really laying the foundation. You define that 100% scope, develop your WBS, and convert those work packages into actionable activities. Then, you sequence everything logically, estimate your durations, and assign the necessary labor, materials, and equipment. And by the way, this is exactly the data you're plugging into scheduling software like Primavera P6 or MS Project. Once your plan is built and costed out in Step 7, Step 8 is the big one, creating your approved baseline. From there, you transition from active planning into active monitoring. You track actual progress in Step 9, analyze any variance from your baseline in Step 10, and if things are slipping, well, Step 11 is where you step up and develop corrective recovery actions. Finally, Step 12 is translating all of this highly technical data into really clear management reports and dashboards so leadership can actually make decisions. Ultimately, it all comes down to this one core truth. The WBS is not just an organizational chart. It is absolutely the foundation for planning, scheduling, monitoring, and controlling your project. Without a logical, rule-bound WBS at the start, everything downstream, your budget, your schedule, your resource allocation, is inevitably going to fracture. So, I want to leave you with a question to ask yourself the next time you boot up a new construction project. When you open your scheduling software, are you just loosely listing tasks to get it over with? Or are you methodically building a true, structurally sound backbone for project control? Because if you master the work breakdown structure, you absolutely master the project. Thanks so much for joining me in this explainer, and I'll see you next time.